Why is grade 1 math so confusing? What are all these circles and lines and equations we're doing? Actually, there's a very specific reason we're doing this, and it's going to help your children to become better mathematicians. Let's take a look. So you might think the easiest thing to do when given 8 plus 5 is just count on your fingers. 8, 9, 10, 11, 12, 13. Or maybe just memorize the fact. Instead, what I want to show you is what we're teaching kids in first grade so you can help them when they come home to you and you see some of those circles. And it's going to have to do with making a 10. And here's what that looks like. I can start with making 8. Here I have 8. If I wanted to say 8 plus 5, I can add 5 more. But what I want to help students to understand is if I'm taking that 8 plus 5, I can say how many more to make 10. Well, let's take 5. I'm going to put 5 into my hand. So I have 5 in my hand, and I'm going to take 2 of them to make a 10. 1, 2, and I have some more left. So I made a 10, I have 8 and 2 more makes 10, and I have 3 more left. And if I think about it like this, I've got 10 and 3 more, which makes 13. Or another way I can show it is with 2 10 frames, and again, I can make 8. So here's 8, and if I have 5 more in my hand, I can make a 10. 1, 2, and how many do I have left? 1, 2, 3. So again, I made a 10 here, and I have 8 plus 2 is 10. 10 and 3 more is 13. So I'm not memorizing the fact that 8 plus 5 is 13, but I'm internalizing and conceptualizing what's actually happening here. So now how does that relate to those circles and those number bonds I talked about earlier? Let's take a look. When I had 8 plus 5, we made a 10 first. So I thought about, let's decompose 5 into 2 and 3. And why did I decompose 5 into 2 and 3? I wanted to make a 10 with 8. 8 and what makes 10? Well, 8 plus 2 is 10, so I can think of this as 10. And how many more? 10 and 3 more. 10 and 3 more is 13. So 8 plus 5 is 13. Now, one of the reasons we're doing this in first grade is to really help your children build an anchor to 10, because if they have an anchor to 10, that will build in future years and we can see future ideas. Let me show you what that can look like. If they have a strong anchor to 10, we can think of 38 plus 5. We can then think, how much more to make the next 10? 38 plus how much more to make the next 10? Well, plus 2 more. And then how much is left over? Well, there's 3 left over. So 38 plus 2 is 40. And 40 plus 3 is 43. So I didn't memorize facts, but I'm using that anchor to 10 to build on information that I know for information that I don't yet know. And then to take it a step further, we can use a number line to add 38 plus 5. And to use a number line to add 38 plus 5, one way I could do it is to draw a number line. And I could start at 38. And I could think, how much more to get to 40, which is a nice friendly number? So I could think 38 plus what is 40? Well, 38 plus 2 is 40. So I can think, how much is left now? How much more for a jump? I had 2. How much is left from that 5? Well, now I've got plus 3 more. And now I can think 40 plus 3 is 43. So I now used a number line to make a 10 or go to a friendly number. 38 plus what number is a friendly number? Plus 2. I know I have 3 more. Thinking about 40 plus 3 is 43. Again, not memorized facts, but understanding making a 10. And in fact, many adults I speak with actually do this on their own already. It may not even be the way they were taught in school, but they learned, hey, I can make a friendly number. I can go to 40. I can go to 100. I can go to friendly numbers and see what's left. This is a natural way many of us think about math, and a way that we want to help students to understand I can make connections and I can understand how ideas are connected to each other. And it all starts back in first grade when we're using 10 frames and thinking about number bonds and breaking things up to make a 10 first.